Hi, thanks everybody for joining. I'm going to use my best announcer voice and say thank you for joining the LogStream 2.0 webinar. Super excited to have all of you guys today, and also this release is phenomenal. And I feel bad about using like all these superlative terms and everything, but wait till you see it. It's super freaking awesome. So on the agenda today, we're going to discuss a little bit about what were our goals, what were the design principles for our 2.0 release. We're going to review a little bit of the architecture so that you guys can understand how it scales, how it deploys, etc. We'll do a live demo, and then we'll get into Q&A. So, and by the way, these are perhaps the ugliest webinar slides I've ever done, but this is how much I had time for. So, let's talk a little bit about what we wanted to achieve with 2.0. The first is that it should be delightful and fun to use, and it really is. And you'll see it when we get into the demo. It's super intuitive. It's super easy to use. It works the way that you would expect it to work, which I think is so critical for enterprise software. A lot of times things don't work the way you expect them to work. We've tried as best as possible. We use it all the time. We use our own software. We play with it. When we try to make it work the way that we expect it to work, and hopefully by proxy, you guys are very similar to the way that we would use the software. The second is the 1.0 management experience is awesome. The ability to capture, the ability to look and monitor where events are flowing, the ability to interactively reshape your data and process the data the way you want. So when we're moving to a distributed system, well, it was always distributed, but the management console only managed a single node of that. As we're moving to a distributed management console, we want everything in the 1.0 management experience. I can't lose anything. That was already great. Let's make sure that we're going to get everything we had there, but now it works across a series of nodes. Because of the way our customers are, a lot of people still on premises in their own data centers. A lot of people also in the cloud, right? They may be running in Kubernetes, they may be running in Fargate. So we have to cover the whole spectrum of deployment from, hey, I've got a bare metal server with 24 cores in it, to I want to deploy in Fargate, or I want to deploy in Kubernetes, and I want to have elastically scalable up and down. So the software has to be fundamentally self-contained. That means that we want to be able to have the same download that I download and work with on my laptop scale all the way up to petabytes of data a day. And it needs to be flexible. So the customers have a lot of differing configurations that they may need to support. So I may have a group of workers out at the edge, and in one of our prospects, for example, is deploying this out in oil platforms out in the Pacific Ocean, and they have logs that they're gathering with very intermittent connectivity, and then they're using us to pare down the logs, compress it before it goes over the wire, and they need to manage that those groups of configurations as well as the centralized data center configurations. And you may want to have a set of workers that work for metrics and a set of workers that work for logs, and so you need to be able to support many different configurations for different groups of workers. And so we knew this in advance by having talked to just a ton of different prospects and customers about their environments. And so we designed the 2.0 management experience to be as flexible as we can for you to be able to mold it to fit your particular requirements. The next is massive scale. So we know people who are moving petabytes of data, petabyte a day. I mean, those deployments are out there. And so therefore, we wanted a management console that would be able to scale to even the largest of those deployments. And come by our booth at Users Conference, and you may, if you follow me on Twitter, I tweeted a screenshot of our management console a day or two ago, pushing 10 gigabytes per second through. We've tested it at larger. The goal is to support petabyte a day scale deployments. And so our single console can manage, many hundreds of cores of Cribble LogStream, processing data at very high rates and very high scale. The next is that it needs to be auditable. And so in big organizations, once you change your streams processing configuration, that's a big deal, because if I accidentally drop data or I change it in the wrong way, I can't usually go back. Right now, you may be able to with your strategy of how you may choose. You may put a full fidelity copy somewhere else, like S3, and then we're actually in the future, probably in the next quarter to 2 quarters, going to give you the ability to replay that data. But generally, when I'm changing my streams processing configurations, I want to do it with very, very high confidence that I've got it right. But I also need to be able to see what exactly was changed and when. Because when things inevitably do go awry and you're trying to track down which portion of the configuration didn't work exactly the way that you wanted to, or more potentially important, like who made a change and when did that change happen, we wanted to make sure that you had an experience that allowed you to see exactly what had happened to the environment and when. And then the last kind of key requirement that we had gotten from our customers is that, hey, I've already got a lot of stuff. Like I've got this CI/CD pipeline, I've got some Ansible, I've got some Salt Stack, I've got my way of managing these configurations. I would like to use your monitoring, but not your management, maybe, or vice versa, or etc. So we designed the experience to be able to work with existing configuration management tools if you so choose. Our deployment will manage the stuff for you, but if you choose that you want to do kind of your own blue-green, or you want to have your own CI/CD pipeline or other continuous deployment, we're there with you as well. If people have any questions, by the way, feel free to pop them into the Q&A section on the webinar, and I'll or send them to me in the chat, and we'll be happy to answer them as we go through. So in Cribble LogStream 2.0, whoops, went the wrong way. There is a Masternode that's handling config management and monitoring. We use the same recommended port we had from before, port 9000. There's a new port that is being used for master to worker communications, and that can be encrypted with TLS as well. And that's just a standard TCP connection where workers are feeding metrics back up. The management node is signaling down to workers that, hey, a new configuration change has been pushed. Those workers will then pull configurations via the API port. So both of these ports need connectivity between masters and workers. And on each worker node, there's also a number of processes. The master node and the worker node have a number of processes that are working. Some are data plane processes. Then there's generally a master process that's handling all of the config management and sort of management work. And I'll show you as I get into the demo what those processes look like in PS, etc. And then the same sort of architecture or marketecture that we've been talking about for a while continues to apply. So your worker nodes here are going to be taking in data via a number of different protocols. It could be metrics protocols, it could be syslog, it could be HTTP, it could be Splunk Universal Forwarder or Heavy Forwarder, it could be Kafka or Kinesis. The workers are going to be that's kind of the data plane concept. So the workers are taking all of the data in. You will be configuring your workers to register themselves in a load balancer or in some type of service discovery system. That's generally outside the scope, but we have some reference architecture type of stuff which we can help you with to show you how to do that, for example, in AWS. And on the Splunk side, of course, obviously load balancing is kind of built into the system. So I believe that we are now into demo. Okay, so let me get out of PowerPoint. And I will stop sharing 1 minute while I make sure that all my stuff behind here is right. Okay, we have one Q&A. Let's see here. Is the master node a single point of failure? Is one of the worker nodes elected to be a master? No. So the master node is the data plane continues whether the master is online or not. So if the master goes offline, you won't be able to log into the monitoring console. You won't be able to log into the to make push changes until the master node comes back online, but it does not impact the operation of the software in the configuration that it was currently in. So I answered that one. Feel free to keep throwing the questions out there, though. That was a good question. Okay, so what we're looking at here in this environment, I will go kind of turn on my my broader configuration here. So this is going to show me an overview of the individual or all of the traffic that's coming in and out. And my laptop's creaking a bit with Zoom, so my apologies. My fans are on and everything, everything else too. So what does it keep doing? Okay, so, and you can see, and we can turn this on live, so these changes will continue to update, and we'll see exactly how many, how much data is flowing in and out at any given time. I can go look at this by sources, by routes, by destinations, so that I can see kind of all the traffic that's flowing through kind of in any given time. And so let's talk a little bit, so monitoring is key to the operation of this whole system. I need to be able to drill through and look in detail at all of the data that's flowing through at any given time. But let's talk a little bit about kind of configuration first, and how, for example, workers and masters communicate and register. So we have a concept of over here in this tab. So workers have a concept of worker groups, and worker groups each have their own distinct configuration of Cribble LogStream. So if you've used the 1.0 management experience, you're going to get the same management experience now segmented towards as many worker groups as you need to have to run your operation. And so same routes and pipelines that we had before. You configure sources and destinations the same way you did before. Knowledge, system settings. So each of these worker groups is sort of a distinct shard of Cribble LogStream configuration. And each of these has a particular version, which I'll show you as we get into kind of making changes. And so each of these worker groups then has workers that then need to be mapped into these particular configurations, right? So workers come in and register. By default, they'll end up in kind of that default worker group, which here I have none of them in because I'm not actually using that configuration. And they get mapped to a set of worker groups based off of these mapping configurations. And so the mapping configurations, all the nodes that check in with a rich set of metadata. So for example, they check in with environment variables that are there in the environment. They check in with the config version, with what master they're configured at, with their particular GUID, and also with a set of tags, right? So in this case, when I deployed my configuration out to the remote nodes, I can actually show you that here. So if we look at my configurations, for example, for Kubernetes, we have some, we basically put in some environment variables here that have, where's that at? Oh, I'm in the wrong one. I'm not in 2.0, here we go. So if we look here, I specify an environment variable that points me towards towards my Cribble master. I set my group and I set my tag names, and that metadata ends up showing up here inside of my mapping configurations. And then mapping configurations use the same type of filter expressions that we use elsewhere in the product. So I can say, hey, in this case, Cribble tags includes Kubernetes, then I want to map it to group Kubernetes. And so once I install these configurations, I can preview them over here as well, right? So if I hit preview mappings, this will go through and tell me which worker group these individual workers are being assigned to. So I can do this all interactively, make sure that I've got everything all kind of shaped up. And when the workers check in to the master, they'll show up here in this workers tab. They'll show me kind of how many CPUs I've got, whether I'm healthy, how much RAM I've got, last config version, so I can see interactively, how many different workers I have and in which group, etc. And then again, the worker group configuration works exactly the same way as it did before. So what I'll show here really quickly. Oh, another thing is, so when I'm on the actual box itself, so this SSH window over here is on my master, right? So when we look here at the Cribble processes, we'll see I've got a number of config helper processes on the master, and then the overarching kind of master process here. Inside of each of the workers, I'll go look inside of one of my containers really quick. And you can see I've got a couple of worker processes as well as the master process here, which is handling the communication with the master node. And so what I'm going to do now is I'm going to, I've got some data generator here. I'm running GoGen. If you guys know me, you know I write data generation software. And so GoGen is going to pop 100 events per second through an HTTP interface to my Kubernetes cluster. And so we'll see this in real time. So as I hit enter here, I'll be able to go here and run a capture. So for example, let's go. Give it a minute to come back. There we go. And so I have a capture coming in from GoGen. I can work with this the same way I always have. So I'm going to hit save. Now I have a new capture here, the way it's always worked in kind of the 1.0 management experience. As I go look here, the data is coming into Splunk. That's my default route. So what I'm going to do now is you'll see here that I'm going to turn this on to all-time real-time. So you can see that the data is continuing to come in. And the first change I'm going to make is, let's just drop this traffic. I don't like it. Let's not do that anymore. So as I change my route here and I hit commit, you're going to see the changes. You can see that I've added a new sample here that's in the configuration that gets checked into source code control. You can also see that I'm now disabling. I'm turning off turning on the drop rule. So I'm going to say, hey, let's drop GoGen. So I hit commit here. Now we see I have a new revision of this configuration, so 5E332. I can see the diff of that versus the configuration that was there before. So a very rich management capabilities, auditability configuration. This makes me really happy. I love these features. Like it's so cool to be able to go back and see what a particular change did and also who did it. So I didn't mention it, but also coming in 2.0 is support for Ldap. So that you can have differing users and et cetera. So I see that I myself, Clint, is the person who's done this. So now what I'm going to do, because now I've committed this change, but it's still coming into Splunk because I have not yet deployed that change, right? So what I'm going to do now is I'm going to hit deploy. All right, and so my new commit hash is 5E332, and we can see one of these guys has already got it. Now it's rolling through. Give it one more second, and then the last worker should check in with the latest version, maybe. And then as soon as these configurations get in, we should see the data start dropping. Okay, everybody's on the latest version. Look, no more data. Woo! Look, Ma, no hands. So yeah, so that's how that works, right? It goes, it works exactly the same way as it worked in 1.0. With rich auditability, with the ability to interactively push new configurations. And then, so let me also show you the changes in the monitoring console. So if I come over here to my routes, I'm going to turn off all of them and just look at my drop GoGen route. And now I can see that this is starting to hit my drop GoGen route. And if I also look at just kind of overall metrics, I should see that the event, if it was granular enough, I could see that the event counts are dropping off. It's 100 events per second. It's not much in the overall scheme of all of my traffic, but it's easy for me to see kind of the changes in real time. And this is rich, right? So I can even browse into, and this is going to be a little slow. I can browse into indexes and sources. There's a few perf bugs. I'm still running a few day old beta copy of the software. So my apologies for the perf stuff. I didn't have time to update my environment for the webinar, but the data tab will show you the full cardinality of that information. I'll let that load in the background while we're running. So one other thing I wanted to show is that, again, that if you're not that familiar with Cribble and Cribble LogStream, just to show you kind of the traditional kind of demo that I'm doing, or how I can work with this data interactively, I'm just going to go through and do kind of a full demo here. So I'm going to create, let's call this reshape weblog, and I'm going to save this. And that same sample that I just worked on here a minute ago, I'm going to bring that into preview. And then I'm just going to do a couple things here. Like, one thing is I'm just going to change a little bit of data. So let's say if the source type access combined, and I'm going to change the source type to be, whoops. Let's change it to webinar. Cool. So now I can see interactively that this has changed here, right? Maybe what I also want to do is let's parse some of this data, and let's do an extraction here. I want to do it from my library. I'm going to do Apache. Type is common log format, and I want to parse Apache combined. Let's do that. Now I'm getting all these kind of rich fields inside of my data. So I'm going to add that there too. And then let's go ahead and this is good enough for now. I'm going to, we've saved this pipeline here. So now I'm going to attach this pipeline to a route. And I'm going to go add a route here. I'm going to say if the route name is reshape weblogs, I'm going to say if the source type, it equals access combined. And I'm going to send it down my reshape weblog pipeline. And we'll leave it at the default output. And I'm going to say that's a final yes. And so what the cool thing about final yes is that actually I was setting it to drop, but now this one's going to match first. And so all of our events should go down that pipeline. I'm going to hit commit. And now I'm adding again, so we can see rich configurability or rich management. I can see exactly what I've changed. I'm going to say, hey, I want to reshape these weblogs. And I'm going to deploy again. And so now I'm going to go here. And oh, what did I say? I said webinar. No, there we go. There we go. And if you look at each of these events here, you'll note that we've added a ton of different fields in here as well, right? So all of this data is coming in as index time fields. It's very, very easy for me to go interactively work with the data, reshape the data. And now this is all being done. It's deploying out to multiple different worker nodes who are now all coming back together and reconverging on the new configuration. And you can see that this happens in pretty close to real time. So one last kind of demo to show you guys is that also inside of my pipeline here, I have a CI/CD pipeline which deploys my my workers to both Fargate and to Kubernetes. And after the 2.0 launch, I'm going to publish some more information about this as sort of a reference architecture. But just to show you kind of how things can operate, is I'm going to start the CI/CD pipeline in the background. I'm just rerunning the same last deployment that I did before. And maybe there we go. Okay, cool. So this is going to start up. It's going to run in Bitbucket pipelines, run a new pipeline in the background. And what this is going to do is this is going to build a new container based off of the latest nightly build. So Cribble next. Super secret. That if you guys go looking there, you can actually find that we generally publish our nightlies out to Docker as well. And so this is building a new container and pushing it up to ECR. And then it's going to tell Kubernetes after this deployment to, hey, go change this service over to this new tag of this particular container. And as that runs, what we'll see inside of Cribble in my workers tab here is we will see these guys start to filter in, and we'll see them come in, get their new configurations, install themselves. This is Kubernetes handling all that side, but install themselves in the load balancer. So here we see them coming in, right? So I've got new Kubernetes nodes coming in. They're checking in, they're grabbing the latest configuration, they're marking themselves as healthy. And then as they get all of their latest configurations, the other nodes are going to go, hey, okay, I'm fine, and quiesce themselves and go shut themselves down. So you see, there we go. So like, super super fast, very easy to kind of to see the health of all of my different worker nodes. And yeah, so there you go. I will pause for Q&A. Let's see, we've got a little bit here, somebody in the chat. Cool. Q&A. Can a worker node also be a master node? How does the pipeline inform the master node? But master node doesn't know anything about the builds. So the master node is the worker nodes are coming up and checking in with the master node. So those two things are somewhat separate. The master node in my case is running on a VM. The worker nodes are all running in containers. When the new nodes come up, they check in with the master. They download their current configurations. And no, a worker node cannot. Well, I mean, the same software can be a worker node or a master node, but there's no there's not a distributed story for the master, right? So and there's really not much state that's being maintained. So we say it's a shared nothing distributed system because we're not distributing out a bunch of state. There's not a whole bunch like a leader election sort of stuff. The worker nodes themselves are largely stateless. And you can see Fargate takes a little bit longer to deploy, and so now the new Fargate node is coming up. So think of the master as sort of is really just there for management and monitoring. It does not impact the data plane. The data plane gets its configurations from the master and will continue to function even kind of without the master. And no, you cannot have more than one master node.
And then given the Git integration with the master, even if the master goes poof, there's ways for you to set up the master so that anytime you're making these Git changes, Clint hasn't set this up on his environment, but you could push those Git changes to a remote repo. And then next time, let's say your master goes away, you could have it so that when the master comes back, you can just check the latest configs from Git and get going from there.
Yep. Anybody else have any other questions? Happy to take them. Let's see. All right. Well, if you have any other questions, I will plug again the Cribble community. So if you go to cribble.io/community, there's an inviter here for our community Slack. You probably got here via the community Slack, I'm guessing, but if you haven't been there before, please go register for our community Slack. If you have any other additional questions, feel free to pop them in there. We'd love to answer them. I hope you agree. We've tried to make this, what does the Git configuration look like? Oh, okay, sure. The Git configuration looks like, let's see, where am I looking at? Is it in
distributed settings?
Distributed settings, there we go. Okay, gotcha. So you're pointing it at a remote URL for Git. How often does the worker check in with the master? 10 seconds by default. I don't know if that's configurable. Is that configurable, Lydia?
It is not configurable right now. We're planning to have the master automatically adjust that depending on the number of workers that are out there. But even at 10 seconds, it's not. It's a very low sort of frequency for that.
And keep in mind that protocol is a TCP based protocol, so they're always up and connecting. And those heartbeats get sent over an established connection that's always running between the worker and the master. Auth options, you need right now HTTP, right? So create a token in GitHub or whatever kind of Git system that you're using, and then you'll put it in like HTTPS foo token at get.foo.com. Awesome. Any other questions? These are great questions. Please keep them coming. Does the master authenticate connecting workers? Yes. There's this token here. So that can be done over SSL, right? So there's a shared secret. And the configuration that I was showing you here, this can also be done. So I set this up in an environment variable. It can also be set up in YAML as well. There's a YAML file that has all the same configuration options. But if you look here, I'm gonna go to 2.0. This environment variable that I'm setting, right? This TCP can also be TLS. And this token here is the token that authenticates that.
And you can also use, as part of the TLS, it's not that easy to configure as Clinton is showing it for this, but there's an option to have mutual cert-based authentication between worker and master.
Is master worker node available? Yeah, so let's talk a little bit about the versioning. We also have some pricing announcements that are coming out next week. So there really is only enterprise, but there are two pricing options for that. One that we call true consumption, and the other is daily ingestion volume. So check back on the blog on Monday. We'll go into more detail about what those pricing options look like. But we're making available LogStream on a consumption model where you don't have to have an annual contract. You pay us for gigabytes in, gigabytes out. How does Cribble configuration move across environments? What's Cribble? Is there a way to move transform parse rules through? Yeah, so I mean, that's a good question. So like, how does my configuration move across environments? I mean, I think, our recommendation would be that you're using a management console with different worker groups for those configurations, and moving configurations amongst worker groups. Right now, it can either be done, via file system. It can be done via the UI in advanced mode. So copying and pasting between worker groups, it works today. It'll be a little bit more ideal in probably future versions 2.1.2.2s, things like that. But totally possible today, and that's how I would manage these configurations as one master, handling dev, QA, prod, and each of those worker groups has their own distinct configuration. Is there a linter configuration? So that's actually kind of a basic property of the system itself. And so as I'm typing these configurations, for example, like, if I have a misconfiguration, we're generally telling you. But a separate linter is a good idea in terms of, hey, being able to run some type of command. Put that in the backlog. It's definitely directionally where we're at. We're trying to make sure that these configurations are valid as they're going out. The UI tries to tell you that, but no separate linter. But that's a good idea. We'll think about it.
Yeah. So the configs are actually tried on the master before. So we won't let you save anything that you do through the UI. Now that said, you could actually go in the file system directly and put in some bad configs. But any configs done through the UI are as if you were trying to do them on a specific worker, and that worker would actually not allow you to save bad configs through the UI.
Thanks. Keep them coming, guys. Is Windows or ARM support on the roadmap?
Yes.
Yes, happy for the build side. If you had an ARM customer, let us know. We haven't run up against, although we're thinking about the ARM stuff for AWS as well, because I don't know if people have looked at the new A instances, but they're like 30% cheaper. Let's see. The system that we're looking at, are these commits being done to? Okay, the system we're looking at is commits being done to get. Yeah, so internally we have get in like the container that I have. We use get. So if you install this on your own VM, you will need get to work with distributed management. And so we have our own Git repo that we are managing, and we allow you to configure a remote Git repo to push those changes up to when you've got them in the shape that you want. So if you're looking here, and again, like I don't have it configured, but the broader full configuration across all the workers is managed kind of up here, and I can say, hey, made a few changes, now new blessed config. I don't have that configured right now. I probably should have done that before the demo, but then there becomes up here, there becomes a deploy or a push button there that allows me to push to the remote repo.
So one of the, I think in the version that you have, Clint, if you go to the distributed settings and just put in anything in the Git setting, we're adding the validation for that, but just say just stop at that. You'll see the different
so
thing
now
that to say. You can push to Git. That's going to fail if you click it now, but
sure, Ledion, you want to answer Jason's question about worker nodes?
I understand. How many worker nodes can the master node handle? Right now, it has been tested with a couple in the low hundreds. We'll take that up. Our goal for 2.0 and was to have it in the thousands. Not sure we're going to be able to test it at that scale, but we'll try our best before 2.0. But the goal for 2x in general is to be in the thousands. Now, that is worker nodes. Each worker node can have a number of processes as well. So for example, you can test with one, we've been testing with some of the largest AWS instances, which end up having around 96 or 90 or something like that. And you can scale up inside a node so you can get the scale out through. So it's a combination of scale out and scale up. Our throughput is measured per core. So we do about 300 to 500 gigs per course, and you can affect that by adding more nodes or by adding more cores to the specific nodes.
Let's see, here we go.
Worker process settings at the end, right there.
Right here, where?
So if you go in general settings.
There. Yeah. Oh, general settings.
Yeah. So in general settings, that could just show you how many processes you can run. How many worker processes can we run on a specific instance? That number could also be a negative number, you could say, from the top of, so if you have 96 cores and you want to allow 4 for the operating system or for general stuff, you could say -4, and then we'll account that correctly.
Okay, so a couple of other questions, and a compliment. Thanks, Ian. Really appreciate it. Yes, there will continue to be a freemium model, so but single node only, and no authentication support, right? So no ability to configure Ldap, no etc. And as you're, anyway, so that's still there. So, and if you are getting over that, then let's chat. Cool. And then Dave, is there support for an HTTPS proxy? Ledion, did that make
HTTPS proxy between management and worker nodes. So port 4200 that we showed, that has to be that's pure TCP. That's our signaling long-lived connection. And we will need access to the if that proxy is transparent to the Masternode. So like without any prefix in the URLs and all that stuff, then we should be able to be fine.
Cool. So another question: is there a way to see if Cribble is dropping any incoming logs or if they're coming in faster? So the metrics that we have are also output in our logs, and right now we would, in any type of alerting functionality, we would defer to destination systems like a Splunk or Elastic, but that's coming. So the 2.0 blog post that I'm writing now will also lay out sort of our vision for where the 2.0 line will take us, and alerting is squarely in there, right? Definitely we want you to be able to get alerts, integrate with other monitoring systems, and be able to detect anomalies and problems in Cribble itself. That also helps offload a lot of the work that you're probably putting onto your log analytics tool today. Our goal is to be able to uplift a lot of that scheduled workload that you're burdening sort of your batch analysis system with into the real-time streams processing. So not yet, but definitely we're going there. All right, these are great questions, guys. I really appreciate it. Any other questions?
So we'll make the architectural stuff available. I'm not sure about whether they're going to be next week or not, but in the very near term future, 2.0 should be GA next week.
Awesome. Yep, next week. So and come by the booth at Conf if you're there. We're definitely rolling it out. Let's see. So is there a recommended OS kernel tuning settings that would be helpful to boost throughputs? Good question, Ledan. Do we have any OS level?
So file descriptors in terms of that's where we've seen people kind of bump into the sometimes there's the default settings. We haven't really done much testing at the in trying to tune the OS or kernel settings, let's say for network or for anything, file system, we don't really do much, but since it's mostly network, we haven't done. Maybe we should start looking into that. Not sure.
All right. Every time I'm about to wrap it up, we get another great question. Here we go. Is there a way to detect back pressure at Cribble at the moment that would lead you to scale the system? So like there's a little bit of a loaded question, like at the moment, right? Certainly you can scale the system automatically, right? And so generally the workload in Cribble LogStream is all it's all CPU bound, right? We're not doing a lot of IO unless the remote system is down. Where events don't even go to disk. Generally, there's not a lot of RAM consumption either, because events come in and they go out, and really RAM consumption is really only for lookups and other sort of stuff. So that means that you can, for the most part, just monitor your CPU consumption, and when CPU consumption is hitting its peak, then scale and add more nodes. And so I don't have it in this particular demo right here, but these workers, these workers as configured, trivial to put Fargate, for example, in an auto scale group that on CPU pressure, it goes and adds nodes, and when there's more CPU than necessary, scales it back down. So being ephemeral and elastic and largely stateless is the design principle that we built the product under, and so it's absolutely designed for those use cases. But like at the moment is a little like it'll certainly auto scale as to the frequency of that, and that's also going to move into the product as well over future versions, right? So because we have all this monitoring, like we will be able to do those sort of call outs and things.
Right. So and there are two dimensions. So as I mentioned before, it's also the scale up. So the ability to chew through more cores inside an instance, and then scaling out obviously involves infrastructure decisions. Like, hey, I'm going to be adding either another container or another VM, which would have ramifications on connecting these things to load balancer and stuff like that. The scaling up within a particular instance, we would actually recommend setting Cribble to be able to chew through all the cores that you have in that machine, and any traffic that's coming in, it should be distributed evenly across all the cores. So there's no real decision to be made. It's just as traffic comes in, more of the cores are being utilized.
Awesome. Okay, I keep saying we're finishing. I'll give it one more second. All right. If you had a question, you were too slow. Awesome. Thank you everyone for attending. We're super excited about 2.0. I think it sets the groundwork for what's going to be an incredibly exciting next year as we build on top of these new foundational capabilities to do stuff that was just never possible before. So super excited to see you guys next week at Users Conference. If you're coming, if you're not coming, then please just send us a note if you've got any questions. Pop into the community. We'd love to talk to you about any use cases that you think are interesting or may work. And with that, I'm going to stop sharing and end the webinar. Thank you, everyone. Wait, one more Q&A. Oh, thank you. You're welcome. All right, thanks, everyone. Have a good day.